So this is our second day of notes on compound inequalities, and we're going to be going over the special cases today. All right. So let's actually start with a warm-up. A couple of questions that we should already know how to do. So let's begin with these two. Please copy them down and please do them. So on number one, we're going to have this compound inequality. You started out by kind of ignoring this. I mean, if you need a push to get started here, imagine that it's a regular inequality. The first step to do would be to get rid of that minus 2 by going plus 2 and plus 2, right? Now the only thing is there are no two sides. There's three sides, right? There's actually a third side. So it's not just what you do to one side to do to the other. It's what you do to the middle, you do to both outside sides. So I'm going to put a plus 2 over here as well. And what do I have left? Well, negative 10 plus 2 is negative 8. I want to bring down the less than symbol, bring down the 4x, bring down the less, then bring down the 10 plus 2, which is 12. My final step is to get rid of that 4 to just have that x in the middle. So I really have a times 4 in front of the x. I get rid of the multiplication of 4 by dividing by 4, and what I do to the middle, I do to both outside sides. So I'm going to divide by 4 out here and divide by 4 over here, giving us our final answer. Negative 2 is less than x is less than 3. Now this is your answer. It's written as a compound inequality with less than symbols right there between the terms. I already know that the areas will be together because it's written as a compound inequality with the smaller number on the left side, the bigger number on the right side with less than symbols. Let me just verify that or demonstrate that to you. We have the negative 2 on the negative side. We have the positive 3 over here on the positive side. Yes, some 0 is somewhere right here in the middle. If we look at this particular part of the compound inequality, it reads x is less than or equal to 3. Open dot at 3. Less than is to the left. And if we look at this one over here, x, and read it backwards, x is greater than or equal to negative 2, then you're at negative 2. I mean, not greater than or equal to, but just greater than. Open dot, greater than's to the right. So it is an area that's together, okay? And that's all the time that you have a compound inequality with the smaller number on the left, bigger number on the right with less than symbols, it'll always be an area that's together. Let's take a look at number 2. That's a absolute value inequality. And on the test this Friday, you will have both compound inequalities where you solve, and you will also have absolute value inequalities and equations for that matter. So on this one, I want to start by reiterating step 1. Step 1 is to isolate the absolute value on the left side of your inequality or equal sign, right? So if you had like a plus 3 over here, right? You would have to subtract 3 and subtract 3. You would have to isolate the absolute value first if the absolute value wasn't already by itself. Let me erase it because there was no plus 3. Or if you had like a times 2 out here in the front, you'd have to divide by 2 and divide by 2. You'd have to isolate it first. Step 1 is to isolate, but again, we don't have a times 2 out in the front. So I just want to reiterate, step 1 is to make sure that it's by itself. So first you get it by itself. Once it's already by itself, which it is right here by itself, you jump to the second step, which is to do your positive and negative situation, all right? Again, the positive situation is writing it exactly the way it is. Even if you had a bunch of negative signs, you just rewrite it identical the way it is without these absolute value signs. So I'm going to do that. 5x minus 10 is greater than 5. Now for the negative situation, same thing. You're going to write it exactly the way it is without these absolute values. But on the negative situation, you're going to flip the inequality symbol and change that to a negative. Everything else stays the same. So we're going to leave it exactly the same, 5x minus 10. We flip the inequality symbol. Instead of greater than, it's going to be a less than. And instead of a positive 5, we're going to make that a negative 5. So we have both situations. We need to solve both. Plus 10, plus 10. We end up with 5x is greater than 15. And keep in mind, guys, we are solving inequalities. You solve those exactly the way you solve equations. The only difference is that on your last step, if you multiply or divide by a negative, you have to flip the inequality symbol. We are on our last step. We are dividing by a positive 5, not by a negative 5. So our answer will remain with the greater than symbol. X is greater than 3. Now the other one, same deal, plus 10, plus 10. We have now 5x is less than 5. Final step, divide by 5, divide by 5. Again, we're dividing by a positive 5, so we do not flip the inequality symbol. Now, those are our answers. However, we need to determine whether we're going to write both of these answers with the word or between them, or if we're going to actually combine them and write them as a compound inequality with the x in the middle, the smaller number 1 on the left side and the bigger number 3 on the right side. So we don't know whether we have the word or between it or if we rewrite it as a compound inequality until we actually look at the areas of each of these answers. So we have to go to a number line. You have to do it. There's no way around it. You go to a number line, put the smaller number on the left side, the bigger number on the right side, and then let's represent this one in blue. X is greater than 3, greater than to the right. And the other one, x is less than 1, less than to the left. So these areas are apart, so I keep the answers apart with the word or right between them. So this is the way you present this answer. You do not write it as a compound inequality with the x in the middle, the 1 on the left, and the 3 on the right with less than symbols. That would be incorrect. You guys following me? Okay, I know I'm kind of going fast here, but so let's get to some special cases. Now, you don't have to copy this down, right? I just want you to listen because we need to understand these special cases with the words or and how it affects how we're going to present our answers. And more importantly, number 7 and 8 from the homework, you need to understand this, the or and the special cases to be able to answer those questions on the homework. So let's begin by just looking at what this says. X is less than negative 2. Less than is to the left. And looking at this one, x is greater than 1. Here's 1, greater than is to the right. And that makes total sense because most of the time, the word or implies that there is no overlap, right? The blue and the red do not overlap each other. The areas are supposed to be apart most of the time. Now, let's take a look at the word and. Most of the time, we use the word and when the area are between two values. Okay, so let's graph this one. X is greater than negative 3, greater than is to the right. X is less than 0, less than is to the left. That makes total sense because the word and most of the time implies the area that's between here and here, right? Or most of the time means apart and means that it's between here and here. Does that make sense? Now, that's what we've seen so far, and I do say most of the time, right? Most of the time, right? Most of the time, because there are some special cases. Let's look at these special cases. So imagine that we are solving a compound inequality. Maybe you have one inequality and then the word or and then another inequality, and you solve both of them. You end up with this answer right here. I want to highlight it. You end up with this answer right here. Okay? So you had an inequality, the word or, and then another inequality. You solve both, you get that answer, and those answers now have the word or between it. Now, most of the time, we would say that's your answer, okay? Like you include both. The x is greater than negative 3 or x is greater than 1. But this is a special case where you do not include both answers with the word or between it, okay? What do I mean by this? Let's actually graph the x is greater than negative 3 in blue. So here's negative 3, greater than to the right. And let's graph the x is greater than 1 in red. Here's 1, greater than to the right. So this is weird because the areas are not apart, even though we're used to seeing the areas apart with the word or, okay? So before we even continue with this, let me do a little activity with you guys. Okay, so ladies and gentlemen, do me a favor. If you have white shoes on, stand up. Actually, you know what? Let's say this better. If you have white shoes on or shorts, stand up. White shoes on or shorts, stand up. Okay. White shoes on or shorts. Okay, so we understand what that means, white shoes on or shorts. You either have shorts or you have white shoes. Okay, now what if I said, if you have white shoes on and shorts, be standing? If you have white shoes on and shorts, stay standing. Right? Okay, so we understand the difference between the words or and, I hope. Thank you for participating. So I'm assuming you guys clearly understand the difference between the words or and. So this guy up here is the answer that we got in our hypothetical situation. We solved one inequality, we solved the other, we had the or between it. Those are our answers with the word or between it. And I graphed it. Here's the blue one going this way forever. Here's the red one going this way forever. And if I ask you, does the value -5 satisfy this answer that has the word or between it? No. So -5 is not greater than -3, nor is it greater than 1. How about -2? Does that satisfy this? What do you guys say? Does -2 satisfy x being greater than -3 or x being greater than 1? Yes, it does. It doesn't satisfy both, but it doesn't have to satisfy both, because the word or implies that it either works for one or the other, and at -2 it works for the blue one, and that's all we need. So the only real answer, even though this was our answer, the only real answer that we should show is that x is greater than -3, and that's it. Does that make sense? I know it's a little confusing. That's like me saying if you have shorts on or white shoes, stand up, right? So as long as you have one or the other, you stand up. So when I say this one or that one, well, anything right here already satisfies this one or that one, okay? Over here is where there's an overlap. This is where it would have to satisfy both. That's where the word and comes in. So let's take a look at that example. Okay, so imagine you were solving a compound inequality. You had an inequality and then the word and then another inequality, and you solve them both. You get your two answers. There's the word and between it. And let's say that this is what we have. Okay, now most of the time the word and implies an area that will be together. Like here's -3, here's +1. Most of the time the word and would be saying that it's between here and here, an area that's together. But like I said, this is a special case. If we look at the x is greater than -3, greater than this way, and over here x is greater than 1, greater than that way. Yeah, it's the same exact inequalities, but it just has a word and instead of or. So what would your answer be right there? Would we write both answers with the word and, or do we just write one of these inequalities, or what would you think? Here's the blue one going this way forever. Here's the red one going this way forever. Let me ask you this. -5, does it work for x is greater than -3 and x greater than 1? No, -5 doesn't work. -2, does it work for x being greater than -3 and x is greater than 1? No, it doesn't. It only satisfies the blue one, right? The x is greater than -3. So in the word or, yeah, that'd be great, but it's and. It has to work for both, so it has to be where the overlap is at. So the overlap clearly begins right here at +1 and to the right. So the only answer that you should write down is x is greater than 1. I want to pause it right there. I want to see if you guys understand this. Ladies and gentlemen, so with that or and knowledge, we should be able to go back to our homework that we started yesterday. Yesterday we started with number 5, we skipped to number 9, we skipped 7 and 8. I specifically skipped them because these were special cases. As you could see, the first one has the word or in it, and the second one has the word and in it. Not only that, there was a typo right here on the second one. It should say 5x plus 6. There was no sign there. Please make sure you put a plus when you copy it down. And this is our homework for tonight. So continuing on to this homework, we have the word or between it. You just solve each of them. I want to begin by adding 3. Adding 3. I will have 2x is greater than 18. I now have a 2 times x. I don't want that multiplication of 2. I'm going to divide by 2, divide by 2. I have the answer x is greater than 9. Now, you got to keep in mind on inequalities, if you multiply or divide by a negative, you have to flip the inequality symbol. We divide by positive 2. Inequality did not flip. That's our answer so far. X is greater than 9. And we also have this very important word or that needs to come down right next to our answer. Okay, now let's solve the other one. Subtract 3. Subtract 3 will end up with negative 7x is less than 14. Final step would be to divide by negative 7, divide by negative 7. We are dealing with inequalities. We are dividing by a negative on our last step, which means that our answer will be the inequality flipped to a greater than. Okay, so you know what? I probably should write this answer over there. X is greater than negative 2. So here's our answer so far. X is greater than 9 or x is greater than negative 2. Now, most of the time with the word or, this would imply on a number line that the areas are apart, right? You have the negative 2 over here on the negative side, the 9 over here on the positive side. Most of the time that we have the word or, it would imply that our areas are apart, going this way or that way. But that's not the case here. It's a special case problem. That's what we're dealing with today. So let's graph one of these at a time. This one is x is greater than 9, greater than's to the right. This one's x is greater than negative 2, greater than's also to the right. Now I'm going to extend them even further. The blue one goes that way even further also, forever. So again, the word or implies that it works for one or the other. It doesn't have to work for both. Right here, the blue and the red, any value over here would work for both. Like, so the number 10 would work for both the x is greater than 9 and x is greater than negative 2. That's where the overlap is at. That's where it's working for the red one and the blue one. That's where the word and would be at. But we don't have the word and right here. We have the word or. So as long as it works for one of them, we're good. We know that negative 10 doesn't work for any of them. We know that 0 works for the red one. So this is where the red one is the first one that's here. So that's the one that we need to represent as our final answer. So just x is greater than negative 2. That is your only answer. You do not need to write or x is greater than 9. That's not part of your answer. It's just x is greater than negative 2. Does that make sense?
Yes.
All right, let me just pause and just do a quick sketch. Let's say we had, another number line. That is the ugliest thing. Okay, I'm sorry. Give me a second. Let's say we had another number line over here. Let's say we had 2 and 4, and let's say both of them were going this way. And you had the word or between them. Let's say we had x is less than 2 or x is less than 4. Am I going to write this whole thing as my answer?
No.
No, I'm not. What am I going to write as my answer? X is less than 4. Because over here it would satisfy both. That would imply the word and. Right here it's satisfying the blue one in this area, and that's all that matters as long as it satisfies one or the other. So you would just say x is less than 4 in this situation. Does that make sense? Okay, now again, let's say, how about this? Let's say instead of, iPad got frozen. Are you serious? It's not working. Well, let's move on to this last one. This one has a word and in between it. So let's solve both. We're going to subtract 15. Subtract 15. We will have negative 5x is less than or equal to negative 15. We are dividing by a negative on our last step, which means that we do what? Change the symbol, flip the symbol, becomes greater than or equal to positive 3. And on this other one, I did mention that there was a typo. We need that plus sign in between the 5x and the 6. So we need to get rid of that plus 6 by subtracting 6. Subtracting 6, we will end up with 5x is greater than or equal to negative 20. Final step would be to divide by 5. Divide by 5. We're not dividing by a negative here, so we don't have to flip the inequality. We shouldn't flip the inequality symbol. It's going to simply be x is greater than or equal to negative 4. And there's the word and between it. So we need to think about the number line here, okay? And let's go to this one in red. Negative 4 is on the left side, on the negative side. Positive 3 is on the positive side. Let me do this one in blue. So x is greater than or equal to positive 3. That's that way. And this other one in red, x is greater than or equal to negative 4. It's also that way. Okay. Now the word and implies that it has to work for both the red one and the blue one. So where is that? What inequality do I write? Yeah, here the word and implies that it has to work both for the red and the blue. You see, from here this way, that's where it's working both. So what is that inequality? X is greater than or equal to 3. X is greater than or equal to 3. That's the only answer. Okay? You don't need the x is greater than or equal to negative 4. Actually, you shouldn't write it, because the word and implies the overlap, both. Kind of like having white shoes and shorts, right? It has to be both, right? Now, let's say you were working on one of these and you had the word and between it. X is greater than 2 and x is less than 4. So if I had that, what would I write as an answer? So let's say you had two inequalities. I didn't show it. Let's hypothetically, we had two inequalities with the word and between it. We did the work, we got an answer. We did the work, we got an answer. There's a word and between it. I put the number 2 here, the number 4 over here. Let's do this one in blue. It says greater than 2. Do this one in red, is less than 4. How do I write my answer? Is it just going to be x is greater than 2? Is it just going to be x is less than 4? It's going to be together because the areas are together. I have to go back to what I was doing yesterday, putting the smaller number on the left, bigger number on the right with less than symbols. That would be your correct answer. Again, if I would have done the inequalities and they would have been apart, then you just put both of them with the word or between it. I think we get it. Can't continue to beat a dead horse here, so I hope you guys get it. If not, talk to me before or after school, send me a text, and let's clear it up.